Good morning, good afternoon, good evening, based on the time zone you guys have joined. Hello, my name is Victor Monga. I'm a community speaker for Virtual Testing Foundation. Today we're going to talk about API Security Series. This is our second session for API Security. As everybody is talking about coronavirus and COVID-19, I came across this dashboards presented by VMware, and I wanted to share with you guys. This has all the stats that country-wise, how many people are actually identified or what's going on. So if you guys are interested, please take a look at it. A little bit of history about virtual testing and what we do. It's a nonprofit organization based out of LA, California. We provide 3 services: education, charity, and support. We are offering online free webinars, trainings, workshops since 2016. We are also providing fiscal sponsorship, donations, and charity events for those nonprofit groups who doesn't have a nonprofit status. We're also providing support and testing for all the cybersecurity solutions who became our partners and who would like us to test their solutions. Now, with further ado, I would like to introduce Inan Shkedi. He's our community speaker, and Inan has been great help to our foundation. He's also a project leader for API security, and he's been in industry well-known entity from quite a while. Today's topic: OWASP Top 10 for API security. Inan, take it away.
Thank you, Victor. Can you see my screen? Let's try it again.
No, I didn't. And here we go. Yep.
Awesome. So, hey everyone. I'm very excited to be here and to talk about OWASP Top 10 for APIs. I hope you all feeling well. It's kind of crazy times, but let's try to talk about fun stuff like the OWASP Top 10 for APIs. So in the previous webinar, we talked about API security and about API in general. Today, what I want to do is to jump into the OWASP Top 10 for APIs and to talk about the top 5 for APIs, from all the way from 1 to 5, and to show you like recent examples and to understand why these issues happen. Just a few words about the OWASP Top 10 for APIs. This is a project I'm leading together with Erzi Alon from Checkmarks. And the main goal of the project is to build a new list for API vulnerabilities. What we found is that the traditional lists for OWASP, like OWASP Top 10 2017, are becoming less and less relevant when it comes to APIs. If you think about issues like SQL injection and cross-site scripting, it's very rare to find them in API-based applications. So there is a shift in the field of application security from traditional application security to modern API-based application security. The OWASP Top 10 for API list addresses this new field of API security vulnerabilities. And today we're going to talk about the top 5. But before we start talking about each one of the top 5, I want to talk with you about a bit more like high level about authorization. What we found as part of the research, and just to let you know, like the top 10 in APIs, it's not a project that just started and ended like in a few days. It was a long process to gain data, to research about the field. We talked with many experts in the industry. It's based on many bug bounties reports. So we basically gathered a lot of data, and then we built the top 10 list. And what we found is that in most of the API breaches from the last few years, you can see that the biggest problem is authorization or access control. They are the same thing. Many APIs suffer from authorization problems. And it made me wonder why. Why authorization is such a big problem in APIs and in modern API-based applications. So I believe there are many reasons for this change, because if you think about it, back in the day, authorization was an issue, but it wasn't the biggest issue in traditional applications. In APIs, it becomes by far the biggest issue when it comes to application security. So I believe there are two main reasons for this shift. So first of all, authorization is a very decentralized mechanism. If we think about other security mechanisms, for example, if we take authentication it's usually done in one component. Usually you have one or a few places to manage your authentication. If we talk about access control, it's completely different. Why? Because access control is something that should be done in many, many different components of the app. For example, if we talk about the function level authorization, companies do it sometimes in the configuration file, sometimes in the API gateway. If we talk about the object level authorization, it's something that needs to be implemented in every controller in the code that receives input from the client. So it's a very, very spread out mechanism. It's not just in one place, it's very spread out. And it makes it very hard and challenging to create a good authorization mechanism. And the second point is that if you think about that, in model applications, you can see many types of users. If you take, for example, Uber, you can see riders, you can see drivers, and then admins. And you can see some complex situations. For example, that one user has two sub-users. In this case, Hugo has two sub-users. And sometimes you have one user that belongs to two different groups. So it's very challenging to track these policies and to deeply understand them. In many companies that I work with, I found that there is no one engineer that understands the full context of the authorization mechanism. Sometimes it's too complex for one person to understand it. And it's like, if only if you take all the engineers in the company and you ask them the right questions, you can get a better image of the access control mechanism, but it becomes really, really complex. So I want to talk about the first and the most common API vulnerability, which is broken object level authorization. You probably know this issue as IDOR, insecure direct object reference. I'm going to explain what is IDOR or BOLA. By the way, we decided to change the name from IDOR to BOLA just because, I mean, IDOR is a cool name, but it's not very accurate. The problem is not with the object reference, which is the ID. The problem is with the lack of authorization. So let's try to understand what is BOLA. We have some app, like for example, Uber, and then you have the user Bob. Uh, Bob took a ride on Uber, and after he took the ride, he wants to download the receipt. Because Bob has taken many rides, the client needs to specify exactly which ride Bob wants to get the receipt of. So the API call to the backend would be gets/receipt/717, which is the ID of the ride. This is the ride ID. And then the payments API processes the request and returns the receipt object to Bob, which is fine because Bob should have access to his own receipt. And by the way, the receipt includes PII, like payment information and the home address of Bob. This is fine. But then an attacker found about this specific endpoint, and he sees that the receipt endpoint contains a receipt ID. And what the attacker is trying to do to change his receipt ID to the receipt ID of Bob. So he sends the same exact API call as Bob. In many cases, the developers in the backend don't validate that the receipt actually belongs to the logged in user. And in this case, the attacker can download the receipt of Bob. And if it was me, if I was the attacker, I would probably write a script to perform many, many HTTP calls to the payments API, to perform many API calls, and I would try to download all the receipts of all the users in the API. And just to let you know, this is the most common API vulnerability by far. I think this is the biggest issue today in application security. And I want to talk with you, if you're a developer, how to implement a good authorization mechanism. And if you're a pen tester, I think it's also important to understand how the authorization mechanism looks behind the scenes so you can exploit it better. So a good authorization mechanism has two main components. The first one is the decision engine. This is number one. This component needs to be able to answer all the authorization queries that the app might have. All the complex logic, all the hierarchies, all the different policies should be defined in this component. And this component, it could be a library, it could be a function, it could be a microservice. It's up to the developers how to implement it. And then the second component is actually many pieces of code. In every controller that the developers write, they need to validate the authorization policy with the decision engine. So the developers that write the controllers need to use the decision engine. Let's see a few examples for how it works, how it looks like. You have user 585, and the user is accessing the API endpoint of update profile. And you can see that as part of the API call, the user is trying to update user ID 616. So on the profile controller, the developers have to check if user 585 has access to update profile 616. And if it's legit or not, I don't really know. It depends on the business logic of the app. Some applications might allow users to update other users. For example, if you have sub-users. So it's totally up to the business logic of the app. A few other examples. Let's say that you have user 232 and he's trying to get the receipt number 777. So the developers who write the receipt controller need to check with the decision engine if the user has access to the receipt. Also in this case, there are many complex scenarios. Let's say that you use Uber. I'm not sure if you know, but you have an option in Uber to split the payment. So you can take a ride with a friend and to split the payment between you. In this case, if you think about that, two users should have access to the same receipt object. So it's a bit more complex to implement it. And then the last example, that you have admin number 616 who is trying to delete user number 888. Is it legit? I mean, it looks legit, right? Because admins should be able to delete other users. It's part of the part of the app. It's part of the features of the app. But in some cases, like in Uber, you have different admins for different parts of the world. So if admin 616 is from California and user 888 is from New York, the admin should not be able to delete the user. So again, it really depends on the business logic of the app. And what I've seen in many APIs where I find BOLA, a broken object level authorization, is that the developers actually implement the decision engine, but they just forget to call the functions from the controllers themselves. So in most cases where you find BOLA, there is actually a function that checks if you have access to the object, but many times the developers just forget to call it. And in this case, you can exploit BOLA. And if you're a pen tester, if you do bug bounties, it's usually a lot of money. A few tricks for pen testers. The first one is IDs in the request body. They tend to be more vulnerable than IDs in the query parameters or in the URL parameters. So I usually focus on these IDs first. The second trick is that if the developers actually implemented an authorization mechanism, sometimes you can use some tricks to bypass the mechanism. How to do it? One example is to send the ID twice. So you send an API call to the receipt API endpoint, and then the first ID is the legit ID. This is an ID of a receipt that you should have access to. But you add another ID parameter, which is the ID that you're trying to download. This is like the victim receipts ID. Another trick is to wrap the ID inside an array. And the reason that those tricks work is that it's not always well, but I think it's important to check it. Sometimes you can actually bypass the mechanism. The reason behind the scenes why it happens is because the authorization mechanism, the decision engine, might be implemented in one microservice. It could be written, for example, in Ruby on Rails. But then the controller itself, the endpoint, the API endpoint itself, which fetches the data, it's written in a different microservice. So for example, this is PHP. And what happens in some cases, if you send two IDs as part of the API call, the first component, the authorization mechanism, would take the first ID. But then the second component would take the second ID. So you would be validated against the first ID, which you should have access to, but the data would be fetched based on the second ID. So those are just two tricks how to bypass authorization mechanisms. By the way, you can follow me on Twitter to find more tricks about authorization bypass. Let's jump into API 2, broken user authentication. So broken user authentication, it's not only one type of problem, it's actually two subcategories of broken authentication. The first one is lack of broken, the first category, the first subcategory is a lack of extra protection. Let's say that you have an API that exposes 5 API endpoints. One of them is to update the profile picture. One of them is to update the device location. Then you have forgot password, web login, and mobile login. So the first two endpoints are not very interesting because they're not related to authentication. But then the forgot password, the web login, and mobile login are much more sensitive because you can use them to authenticate to the app. And that's why they require extra layer of protection. And all the users that are trying to send API calls to those endpoints need to get through this extra protection layer. What is an extra protection? It's a great question. And there are a few different components that you need to implement as part of extra protection for authentication API endpoints. The first one is user lockout. So let's say that you have an attacker who is trying to reset the password of a specific user. After the attacker sends, like for example, 5 or 10 API calls to reset the password of a specific user, you should lock out the user that the attacker is trying to reset his password. For example, for 5 or 10 minutes. And then you have other types of protection, like CAPTCHA. If you see too many attempts to log in to, like for example, too many API calls to the web login endpoint, you should block the IP address or to show the attacker a CAPTCHA instead. Same thing about credential stuffing and anti-brute force. And just in general, if we talk about extra protection for authentication API endpoints, there are two types of extra protection. One of them is based on the victim. If you see that someone is trying to attack a specific victim, you should block access to this user for a few minutes to make sure that the attacker can gain full control of the user. Then the second type of the extra protection is based on IP address. So if you see too many API calls from one user to the authentication endpoints, you should block this IP address. The second subcategory of broken user authentication is more around the field of security misconfiguration. You can see on HackerOne that many bounties, many prizes have been given because of this silly thing. In Joe tokens, developers allow algorithms equal none. And then it allows you as an attacker to change the content of the Joe token and basically to log in on behalf of any user that you want. A few other examples for security misconfiguration when it comes to broken user authentication is tokens that never expire, weak passwords, and the weak forgot password tokens, which is easy to guess. I want to talk with you about the API tree, excessive data exposure. Personally, this is one of my one of my most favorite vulnerabilities, and it makes your life as a pen tester very easy. Why? Because this is a situation where that instead of performing a complex API pen test, instead of looking for complex vulnerabilities and to try to exploit them, the APIs leak PII of other users by design. So the API basically give you a gift. You can see details of other users. Let's see an example for that. Let's say that you use some dating app like Tinder. It's pretty common here in San Francisco. And then you swipe right, you swipe left, then you see the profile of Bob. You can see the public details about Bob. Bob is a minion, and you can see his hobbies. I would swipe right for sure, by the way. And if you take a look at the traffic between the client and the API, you can see the following pattern. The Tinder app, the client sends the following API call of get/user/717, which is the ID of Bob. And the response from the API contains all the public details about Bob, which you can see on the screen itself, like the name and the hobbies. But more interesting than that, the API exposes the private address of Bob, which is PII. The API should not expose this data to the user. What happens in many cases is that the developers on the backend, they rely on the developers on the front end to filter out this data. So you cannot see it as a regular user, you cannot see it on the UI itself, but as an attacker, it would be very easy for you to sniff the traffic between the client and the API and to see the sensitive data. Filtering out sensitive data on the client side is always a bad idea. You should not do it as a developer. And it's kind of funny because if you think about it, it's a very interesting situation. The APIs just leak PII by design. It took me a while to understand why it happens. I think the main reasons is, first of all, the API economy and the REST standard. They encourage developers to develop API endpoints in a very generic way. You can see many times that one endpoint is being consumed by different features or even different type of users or different clients. So instead of implementing different endpoints for each client or for each user or for each group, developers just create one endpoint that return a specific resource. In this case, it would be the profile of the user. And then the developers use two JSON or two string functions from the ORM or the model itself. And what happens, developers, instead of returning specific details about this object, they just return the raw object, the full JSON object. And I think the main issue here is that developers don't really think who is the consumer of the data. They just prefer to expose the full JSON object. Yeah, I want to show you an example for a recent breach. It was found by Alex Thomas from Pentest Partners. It was a problem of excessive data exposure on the TreeFun app. The TreeFun app is some type of dating app for people who are willing to add other partners to their relationship. It's basically for swingers. What Alex found is that when you try to find for another person to join you and your partner, there is an API call to match users. The response from the API call returns all the users in your area. So you can start swiping right and left. And inside this JSON, I mean, it's legit to return details of other users in your area because the client needs it to show you the users. But what the developers did, they returned the full JSON object of the user, including private information, private photos that the user sends to other people and they don't want to share with everyone, their birthday, date of birth, and a lot of other sensitive. Can you see my screen?
Yep, you're good.
Awesome. So let's talk about what is rate limiting, lack of rate limiting in terms of business logic based. So many times you have endpoints that are more sensitive and the developers need to protect them. What does this mean? If we take, for example, Expedia, they have an API endpoint of get flight price. If you are trying to if you are trying to access this endpoint too many times and to get the prices of all the flights, they would block you. Why? Because this is part of the IP and they want to prevent scraping from their APIs. Because their competitors might want to know exactly what are the prices for all of the flights. And they will try to block users from accessing this endpoint too many times. Or if we take, for example, the API of AllTrails. AllTrails is a very nice app. You can download it and to find hikes around you, some trails and hikes around you. So if you're visiting San Francisco, you can find the cool hikes in Berkeley and in Yosemite. And the IP of AllTrails is basically the database of trails. So as a user, you should be able to access 10 or 20 trails every day. But then if someone is trying to scrape the API and basically to get all the details of all the trails, basically to steal the trails, they will block the user. Why? Because they don't want their competitor to get all the trails because it's some type of sensitive information. So you want to limit your users from accessing those endpoints too many times. The second type of rate limiting that should be implemented is for heavy API endpoints. Every API exposes endpoints that it takes a lot of resources to process. They expose functions that are very heavy. Let's see a few examples. In Expedia, you might have the option to export a receipt to a PDF. What usually happens behind the scenes, the developers take the HTML of the receipt and they convert it using a third-party library to a PDF. This is a pretty expensive operation. It consumes a lot of resources on the backend. So you don't want to allow your users to convert receipts to PDFs too many times. That's why it's needed to have, in this case, a rate limiting mechanism, for example, that allows users to access this API endpoint only 40 times every day. If we talk about the AllTrails, let's say that you have get updates endpoint, and usually users send an API parameter between 1 to 100, but then some users send a limit field of a very long number. So the API would try to fetch a very large number of records from the database in order to process this API call. And it could lead to denial of service. So you want to protect your APIs against denial of service. In this case, you should just make sure that the limit field is in a specific range. It's some type of input validation. So this is the last vulnerability that we are going to talk about today. It's called BFLA, Broken Function Level Authorization. This is another type of access control problem that basically the API exposes a functionality that should be exposed only to admins, but the API exposes this functionality to regular users. For example, you have some API, it has a few sub APIs, for example, admin API, writers APIs, and a drivers API. And you have an admin and an attacker. The attacker has a regular account of a writer on the app. And then the admin is trying to perform the following API call to delete a specific user. And this is fine because this is an admin. The admin should be able to delete a specific user. But what happens if the attacker is trying to perform the same exact API call to delete user number 717? So the problem here, it's not about the object ID. The ID is it's not the problem. The thing is that the API should not be exposed to regular users. This functionality of deleting a specific user should not be exposed to anyone else just to people that belong to the admin group. Many times the developers on the backend, they forget to validate that the user who is trying to access the API endpoint actually belongs to the right group. It's not a new vulnerability, but it becomes much easier to exploit in APIs. Why? Because API endpoints are more predictable. The REST standard encourages developers to develop APIs in a very standardized way. And let's see how you can leverage it to find admin endpoints. So we take, for example, an app that exposes two different features. One of them is to update the user profile, and the second one is to delete a user. If we talk about a traditional multi-page application, the HTTP call to update the user's profile would look something like get/app/usersview.ispx, and then you need to mention the user ID as part of the query parameter. And the HTTP call to delete a specific user, this is a function that exposed only to admins from the admin panel, would look something like post/app/admin panel/user management, and then in the body of the request, you need to mention the action that you want to perform and the user ID. So it will be very challenging for a pen tester to guess this pattern. You need to guess the action, the URI. It's not very easy to exploit it. So even if the developers did not implement the right access control, it would be hard for pen tester to predict this entry point. Fortunately or unfortunately, it depends on what side you are on. In APIs, it's much easier to predict these endpoints. So you have an API endpoint to get details of a specific user, for example, get/API/user/user ID. And in order to find the function that deletes the specific user, you just need to change the HTTP method from get to delete, and you found the admin endpoints. It's very easy. Just a recent example for a broken function level authorization. It was found on Shopify. It was found by UZ on a HackerOne. The researcher gained $20,000 because of this breach. What happened is that the developers in Shopify did not validate the user belongs to the admin group, and they exposed an admin function to the user that allows the user to assign himself as a collaborator, which is some type of an admin. So the attacker could basically assign himself as an admin of any shop on Shopify. This is a classic example for a broken function level authorization. It allows you in many cases to perform some type of privilege escalation. Yeah, so this is the last slide. I hope you enjoyed it. I'm gonna move it to Victor now.
Hey, thank you. All right, let's see if we have questions on the screen. So one question we have received in, what about the API security 6 to 10? When are you going to deliver that?
It's gonna be in one of the next webinars.
Okay. Second question we have received, can we encrypt the data for APIs when it transmit between the vendors and the customers?
Sorry, can you please repeat the
Sure.
question?
Yeah, one of the questions is, can we encrypt the data for API when it transmit between vendors and customers?
Yeah, definitely. So first of all, it's very important to use HTTPS, to use a TLS to encrypt the data from the client to the server. This is the basic practice. You can also see some applications, mostly banking applications, that perform another layer of encryption in the application layer. So if you perform the second type of encryption, that's like it's another layer of encryption, it's much harder to debug the app. So not many companies do it, but it makes the life of the attacker a bit harder before they can exploit the app.
Awesome. Okay. Those are the only questions I see it. All right. Well, thank you so much, Inan. Thank you for explaining API security 1 to 5, and we look forward to your 6 to 10 session. I hope everyone enjoyed it. So we have few other webinars for March and April scheduled already. One is on 27th. The links are pretty straightforward. 27th of March, if you type 03/27/2020.virtuallytesting.com, it will point you to our webinar link. We have it on one on 28th. It's regarding ASVS project of OWASP. Then we have one cloud penetration testing webinar on April 11th as well. So people who wants to learn about cloud penetration testing, please come and join us. All of this session is recorded and all the slides will be posted on our LinkedIn. If you would like to get in touch with us, please follow us on twitter.virtuallytesting.com, linkedin.virtuallytesting.com, and youtube.virtuallytesting.com. Once again, thank you, Anand. Thank you so much for joining. Thank you.
Thank you, Victor. Stay safe. Bye-bye, guys.